Hello, my dear students. Hope you are all well. And today we came here to discuss some typical organic transformations, especially for different kinds of entrance examination after plus two. Okay, and this reaction is very useful also in your board exam in plus two. Okay, so without wasting time, let's move to the whiteboard. And as in my previous classes, I request all of my dear students to please subscribe my channel so that I'll be motivated and I can bring some more classes in front of you, which will certainly help you. Okay, and again, if you do have any queries, any askings, write down all of your askings and queries and doubts in the comment section. Okay, I'll get your comments, I'll get your doubts, and I must try to help you to solve your problems. Okay, and also please note, if you want the PDF formats of every classes, so please write down also in the comment section. Otherwise, one thing, if you don't need any PDF format, just keep your notebook handy and write down all the things I generally write on the whiteboard by pausing the videos. If you don't write in the notebook, it will not help you to memorize. Okay, so let's start. So today our topic of discussion is the Wittig reaction. It's very common reaction, common name reaction in organic chemistry. So this is the Wittig reaction. Today's topic is Wittig reaction. Wittig reaction. It is generally pronounced as Wittig reaction. Wittig reaction. So the spelling is Wittig, Wittig, Wittig reaction. So before going to discuss the Wittig reaction, actually we have to know one terms. We have to coin one terms. This is Ylides. Okay, Ylides, Ylides, Ylides. So what are the Ylides? What are the Ylides? So my dear students, what are the Ylides? So generally, uh, so what are the Ylides? So Ylides is a natural molecule. Ylide is a natural molecule. Ylide is a neutral molecule, not natural. Ylide is a neutral molecule. Ylide is a neutral molecule, but charge separated. Charge separated. So what is charge separated? Charge separated means there exists a positive charge as well as a negative charge. So overall the charge is neutral. Overall, no charge exists on the molecule. And where there exist there exist uh, negatively there exists a negatively charged carbon atom and a positively charged heteroatoms. So what are the heteroatoms? Heteroatom means atoms, not carbon, other than carbon. So what are the heteroatoms? nitrogen, it can be phosphorus, sulfur, etc. All these are the heteroatoms here. Okay, so please write down these. What are the ylides? So I hope the whiteboard is visible. If it is not visible, write down the comment section. Okay, so general formula of the ylide and the example of the ylide: PH3 P plus CH2 minus. So it is an example of a very good ylide. Look here, the negative charge is on the carbon atom and the positive charge is on the heteroatom, that is phosphorus. So it is what is the name of the ylide? The name of the ylide, the alkylidine alkylidine triphenyl. So there are three phenyl atom, the three phenyl moieties. So alkylidine, this portion is called alkylidine. This is called alkylidine triphenyl triphenyl phosphorans. So this is called triphenyl phosphorans. So this is a type of alkylidine triphenyl phosphorans. So generally the formula of the alkylidine triphenyl phosphorans is basically like this. So there is so in place of the two hydrogen atom, you can write two alkyl group, which can also be hydrogen. Okay, so this is a general formula of alkylidine triphenyl phosphorans. This is a good example of ylide, and it is also known as the Wittig reagent. So this ylide, this is a ylide, this is a type of ylide, this is a member of the ylide family, and this ylide, basically this ylide is called Wittig reagent. Okay, so it is called Wittig, 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 or you can say Wittig reagent. This is called Wittig reagent. Okay, my dear those friends, this is called Wittig reagent. So I hope you all can write this. So now move. What is Wittig reaction? So what is Wittig reaction? Wittig reaction, the reaction of an aldehyde, the reaction of an aldehyde or ketone, with with alkylidine triphenyl phosphorans to form alkene, to form alkene. Alkenes, okay, is known as Wittig reaction, is known as Wittig reaction. So we can take an example. What is this? This is cyclohexanone. Cyclohexanone is a ketone. Cyclohexanone. This is cyclohexanone. This is cyclohexanone. So this is cyclohexanone. When this cyclohexanone is treated with triphenyl phosphonia, alkylidine triphenyl phosphorans, alkylidine triphenyl phosphorans, it gives like this CH2 and pH3. pH means phenyl. So this is called methylene. CH2 group is called methylene group. CH2 group is called methylene group. So this is called methylene cyclohexane. Methylene cyclohexane. Okay. So now uh, try to cover the mechanism in short. I am not going to discuss detailed mechanism, but just mechanism in short. This is the cyclohexanone, and this is the triphenyl. So this negative part should attack the carbon center, that is carbonyl carbon. Carbonyl carbon is a electrophile. Carbonyl carbon is an electrophile. So it becomes like this. O minus, that is CH2, try to understand the mechanism. I repeat, this dipolar moiety, it is dipole because there is a charge separation, negative charge on the carbon atom and the positive charge on the phosphorus atom. Okay. So then the negative charge on the carbon atom attacks on the carbonyl carbon, and the oxygen atom get negative charge. Okay. So now next step, the negative charge attacks on the phosphorus, uh, and then it becomes like this pH3 C, and in the very next step it becomes like this CO CH2 pH3 PO. So this is triphenyl, that is triphenyl phosphorus oxide. This is triphenyl phosphine oxide. This is triphenyl phosphine oxide. Okay. Write down the notes, write down the equations, write down all the equations I have written on the whiteboard, otherwise you all forget this. Okay. I'll move on. Next. So what I have written, what we have discussed, we have discussed the Ylides. What are the Ylides? I repeat, what are the Ylides? What is the Wittig reagent, and what is the Wittig reaction? The general scheme of Wittig reaction and the detailed mechanism of Wittig reaction. Now we are going to discuss some typical example of Wittig reactions, which are generally asked. And the previous examples also is a very typical. Other than we are going to discuss other than this some more typical examples. Okay, so what will form? What will form if this example, if cyclohexanone, if cyclohexanone is treated with this Ylite, PH3P double bond CHOCH3, and then treated with H3O plus. What happened in this particular reaction? In place of alkene, aldehyde will be formed. Okay, so what happened at first? PO CH3. Okay, so what happened? The negative charge. So charge separated structure. Here the double bond. Here the pi bond. The pi bond sits on the carbon atom. It becomes negative, and the phosphorus atom become positive. So actually, you should not be confused, students. You should not be confused if here the double bond exists. Actually the pi bond will be shifted on the carbon atom adjacent to the heteroatom. It can be phosphorus, it can be nitrogen, etc. Here in case of here in this case phosphorus. So the pi bond shifted on the carbon atom and convert the carbon atom into negatively charged carbon on, and the heteroatom phosphorus makes positive. And this negative center attacks the electrophile. What is the electrophile? The carbon center is in electrophile, and it becomes negatively charged. Here CH OCH3. Here attacks here. So the oxygen atom OCH3. Very next step, it becomes CHOCH3. Okay. So this alkene is very unstable, which in presence of H3O plus, look, should not forget the use of the H3O plus, otherwise the reaction will stop here. But as we use H3O plus, the reaction will move some one more advanced step. Okay, so this alkene will be converted into the corresponding aldehyde. So what we get? We get this aldehyde. Okay, So it is a very good example and often asked in the entrance exam. And write down this example. Yeah. Next. So what happened if such kind of question being asked? CH3O. What is this? This is the kind of oxygen. This is called oxygen. Epoxide. This is called oxygen. Epoxide. Okay. So here the two methyl groups. Here the two methyl groups, the oxygen compound, this this bond, and this bond lie in the same plane, and above the plane, two methyl groups lies. So as the two methyl group lies on the same plane, this is called cis. So this is cis 2 comma 3 dimethyl 2,3 dimethyl oxygen. This is called 2,3 dimethyl oxygen. So when this oxygen is treated with triphenyl phosphine, what happened? Look, triphenyl phosphine. So when this react with the triphenyl phosphine, as the triphenyl phosphine has the uh, lone pair of electron, this lone pair of electron basically attack one of the two center. This become this, and so negative charge, CH3, and here positive charge. Okay, now one rotation will be occurred. So the plane is rotated what extent? 180-degree rotation. So as the plane rotates 180-degree, so as the plane rotates 180-degree, the CH3 group here lies on the, so one here 180-degree rotation. Why? Why this rotation is occurred? Because the rotation is occurred to make the bond between the negatively charged oxygen and the positively charged phosphorus. Otherwise, the bond cannot be established. Now they become nearer. But what happened here? The hydrogen below the plane here becomes above the plane, and the methyl here becomes below the plane. Now what happened then? So actually, then it becomes trans-butene, trans to butene. It becomes trans-but to in. This is the final product, trans-but-2-in. And write down. I once again request you to write down all the things I have written on the whiteboard. Okay, my dear friends. So hope you all enjoyed this class. And today we should stop here. And before leaving the class, I must request all of my dear students, please subscribe my channel, and if you do have any doubts, queries, drop in the comment section. And if you need the PDF format, please write down also in the comment section. I will provide you free of cost. Okay, so hope you all enjoyed and you all learned something. And till then, we have met in our next class. Till then, goodbye. Stay tuned.